Hello, good morning, good afternoon, good evening to you wherever you are in the world. This is Engineer Samuel Anekan. Welcome you to this channel. So we'll be looking at a further additional mathematics topic called partial fraction. This is going to be our first lesson on partial fraction. So we're going to look at partial fractions from the scratch. Although to actually do very well in this subject, you need to have a good knowledge of quadratic equations and polynomials. But actually, even if you don't have the knowledge, you can still try to follow along. Then if you have difficulties, I'm going to refer you to a video on quadratic equations and polynomials. So before we go on, if you're not subscribed to this channel, please go ahead and hit the subscribe button and hit the like button also, because you are going to really enjoy this video. You're really going to enjoy this lesson. So we're going to start right away. So if we have a fraction such as 3 over 4 minus 2 over 5, we can actually simplify this fraction by taking the LCM of 4 and 5, which is 20. So this is going to be LCM of 4 and 5 is 20. How many 4 do you have in 20? How many times does 4 go in 20? That is 5 times. So that becomes 5 times 4. Sorry, 4 in 20 is 5. So that becomes 5 times 3. Minus how many 5 do you have in 20? You have 4 5s in 20. 5 times 4 gives you 20. So since 5 in 20 is 4, you will now say 4 times 2. So at the end of the day, 5 times 3 is 15. 4 times 2 is 8. All over 20. 15 minus 8 is equals to 7. So your final answer is 7 over 8. Okay. Now, how about when you have an algebraic fraction such as 2 over 3, 2 over x minus 3, 2 over x minus 3, minus 4 over x minus 1. You can similarly find the LCM of the denominator, both denominators. Here we have a linear equation. Sorry, a linear expression. This is a linear expression. This is another linear expression. So the LCM of x minus 2 and x minus 1 will give you, LCM is going to be x minus 3 into x minus 1. So at the end of the day, solving further, this is going to be x minus 3 in x minus 3, x minus 1 will give you x minus 1. So x minus 1 times 2, this will be 2 into x minus 1 minus, then for this side, x minus 1 in the LCM, which is x minus 3, x minus 1. X minus 1 will cancel x minus 1, so you are left with x minus 3. So at the end of the day, that will be 4 times x minus 3. So you have 4 times x minus 3 all over the LCM, which was x minus 3, x minus 1. So at the end of the day, right now, you can now go ahead and expand the numerator. What do we have? 2 times x, you have 2x. 2 times minus 1 gives you minus 2. Minus 4 times x gives you minus 4x. Minus 4 times minus 3 gives you plus 12. So now we now collect like terms together. We now bring the like terms together. So you have 2x minus 4x. 2x minus 4x, then minus 2 plus 12. Minus 2 plus 12. Then let's simplify. 2x minus 4x gives you minus 2x. Then minus 2 plus 12, your answer there is plus 10. So you can write this as 10 minus 2x. This is the same thing as plus 10 minus 2x. There's no point putting a plus once it is the first number that in your expression. So this is our numerator now. So we can now bring it, combine it with the denominator. So at the end of the day, we have that 10 minus 2x all over x minus 3 x minus 1. So this is the solution to this. If you are asked to simplify this, this is what you get at the end of the day. So you started from the LCM and you walked all the way till you finally arrived at this. Okay, very, very easy to solve. But now the question is, how about if you were given this fraction, algebraic fraction here, this algebraic expression, and you are now asked to simplify to this form, break it down to this form? How are you going to do that? How? You are given 10 minus 2x into x minus 3 over x minus 1, and you are now asked to simplify it into this form. Simplify into this form means to resolve it into partial fractions. Here you have one side, here you have another side. This is a partial fraction, this is another partial fraction. So how are you going to go about that? Yeah, it was very easy. We could find the LCM just the way we as in simplified fractions, normal fractions. We could just apply that concept, find the LCM, find out how many times the denominator goes on in the LCM, and we go ahead and solve just as we did. I just showed you. But how about if you were given this one and now asked to resolve this into partial fraction? How are you going to go about that? How? So that is what partial fraction is all about. Okay, so I'm going to show you the reverse process right now. Supposing we were given this partial fraction, 10 minus 2x over x minus 3 into x minus 1, and we are asked to simplify into partial fraction, resolve into partial fraction. How we are going to go about this? Now if you look at this, this is a number, this is a number, this is a number as well. So you have the first side, this first x minus 3 is on the first side, you have x minus 1 on the other side. So that is just the process we will follow to resolve this. So let me show you what we're going to do to actually resolve this. So we are going to back solve. We're going to solve from this and arrive at this. That is resolving. When you are asked to resolve, assuming you are given this expression here, this algebraic fraction, and you are asked to resolve it into partial fraction. So when they are asking you to move back here. So now I just want to show you how to do that. So we have 10 minus 2x all over x minus 3 into x minus 1. So at the end of the day, your partial fraction is going to look at this, something like this. So the only information that you have is that you have x minus 3, x minus 1. But how do you go? Nothing tells you how you can actually move from here to this 2 and this 4. So, but this is the guide. This is how it's going to look like. Your partial fraction is going to look like when you actually express in partial fraction. It's going to look at this way, similar to something like this, of this nature. So that 2 you don't know. So we are going to use an alphabet to represent the 2. So the first thing you're going to do, you have x minus 3, okay, then plus all over x minus 1, okay. So this is what you're going to do. So on this side, you have A. On this side, you have B. You have a B. So you are going to write A over x minus 3 plus B over x minus 1. This A stands for this number which you don't know. In this, since you want to solve backward, you don't know whether it's a 2, you don't know what it is. But the A is representing whatever, which in this case is 2 actually. And your B is representing the 4. Okay. So the question here is A is a constant, that is a pure number. It's not a variable, it's not an alphabet. B also is a constant, is a number. So at the end of the day, if you solve correctly, we're going to arrive at A is 2 and B is 4 or minus 4. Okay. Okay, so let's move ahead. Having arrived at this right now, so what do? We find the LCM here. The LCM here is x minus 3 into x minus 1. The LCM of x minus 3 and x minus 1 is x minus 3 into x minus 1. So x minus 3 in the LCM, x minus 3 will cancel x minus 3. So you are left with x minus 1. So that is going to become A times x minus 1. You now have A times x minus 1. Then plus, for the B side, you're going to have x minus 1 in the LCM, which is x minus 3 into x minus 1. X minus 1 will cancel x minus 1. So you are left with x minus 3. So this becomes B into x minus 3. Okay. So you have 10 minus 2x all over x minus 3 into x minus 1. So this is the left hand side and this is your right hand side. So at the end of the day, here you have x minus 3, x minus 1. Here you have x minus 3, x minus 1. So denominator and denominator here are the same. So which also implies that numerator and numerator will also be the same. This is actually an identity. And in identity, left hand is similar to the right hand side. So since the numerator is equal to numerator, the denominator will also be equal to denominator. So we can just pick out the numerator. What we are looking for is A and B. So let's pick out the numerator. We're going to have 10 minus 2x equals to A into x minus 1 plus B into x minus 3. So having picked out the numerator, so we can go ahead and we are looking for A. So how do we solve for A? So what we're going to do is that we will choose a value for x that will eliminate either A or B. We'll look for a value that when we choose that value and make x equal to that value, it will eliminate either A or B. So first of all, let's start with the one that will keep A and eliminate B. We want to eliminate B. What value that one we choose will make B 0. For B to be 0, that means this side must be 0. Once this side x minus 3 is equal to 0, once x minus 3 is equal to 0, then 0 times B is going to give you 0. So B will not exist again. Then you can now solve for A. Okay. So what value will enable us to will make this side, this x minus 3 linear equation, it becomes 0. Will make the x become 0. Let's look at that. So for that to be 0, we must have that x minus 3 should be set to 0. If x minus 3 is set to 0, then x is equals to 0 plus 3. You bring this to this other side, it becomes a plus. So 0 plus 3 is what? 3. So that means x is equals to 3. X is what? Equals to 3. So x equals to 3 will make b. When you put 3 here, 3 minus 3 is what? Going to be 0. 0 times b gives you 0. So you have that when solving for a, when x is 3, you're going to have 10 minus, you are going to replace, put when you have x, wherever you have x, you're going to put 3. So here you have x, you have 3 equals to a, this is x minus 1, which becomes, in place of x you put 3, plus b, then 3 minus 3. So this is 10 minus 2 times 3 is what? 6. This is a, 2 minus 1 is what? 2. So you have 2a there. Then plus b times 3 minus 3 is 0. So at the end of the day, 10 minus 6 is what? 4. Then you have 2a. This is 0, which implies that 2a plus 0 is 0. So you have 4, from here you have 4 is equals to 2a, from which if you solve for a by dividing by 2, you're going to have that, divide both sides by 2. From here you have that 4 equals to 2a over 2 divide both sides by 2. So you have that a is equals to 2. So your a is equals to 2. A is what? Equals to 2. Your a is equals to 2. So we've gotten that a is what? A is 2. Our a is equals to 2, which is the 2 we got here. Okay, that is the 2 we actually got there. So let's solve for b. So let quickly, I hope you have your pen and your paper and you're copying everything. You need to have an exercise book. You have a notebook with a pen whereby you always copy things down and follow. This will actually help you better. So next, we've done justice to a. We've solved for a by making b 0. So now we're going to make a 0 and solve for b. So let me rub this off. So for b, such that where what will make a 0? What will make a 0? For a to be 0, then this side must be 0. So we have that a into x minus 1. X minus 1 was 0. And that can be possible when x minus 1 is equals to what? Set x minus 1 equals to 0. From here, x is equals to 1. Minus 1 goes to that side, becomes plus 1. So x is equals to 1. So when you set x equals to 1, 1 minus 1 gives you 0. 0 times a, this side becomes 0. So let's do that now. So wherever you see x, we're going to put 1. 1, 1. So you have 10 minus 2, your x becomes 1, equals to a, your x here becomes 1 minus 1, plus b, your x here becomes what? 1 minus 3. So at the end of the day, this is 10 minus 2 times 1, 2. This is a, 1 minus 1, 0. So this is going to be times 0, plus this is b. 1 minus 3 is what? Minus 2. So 10 minus 2 is what? 8. Equals to 8 times 0, 0. Then minus 2 times b minus 2b times a plus 2 minus. Plus times minus is minus. 2 times b, you have 2b. So at the end of the day, so from here, 8 is equals to 0 minus 2b. We have minus 2b, the 0 is ignored, 0 doesn't do anything there. So you have 8 is equals to minus 2b. From here, we solve for b. This is going to be divide both sides by minus 2. So you have minus 2b over minus 2. Then 8 divided by minus 2. From here, minus 2 cancels minus 2. 2 divided by 8, this is 4. So b is equals to minus 4. So your b, we've solved your b as equals to minus 4. So originally our a, we got a equals to 2. Our b is what? Minus 4. Okay? So just take your time with your pen or your paper and painstakingly go over what I've done. You saw how I solved for a and how I solved for b. The key to solving for each of these coefficients, these constants a and b, is to look for something that will make that one of them 0. So here we set x minus 1 equals to 0 from where x is equals to 1. When we put x equals to 1, this becomes 0. Over here, when we put x equals to 3, by using the fact that x minus 3 is equal to 0, then x is 3, then this side is 0 and b is 0, and we are able to solve. Now we've gotten the value for our a and b, so our problem is solved. What remains now is just where you have a, you're going to put 2. Where you have b, you're going to put minus b, minus 4, sorry. So you have minus 4 there. Where you have b, you have minus 4. Where you have a, you have 2. So let's go ahead and do that and plot in our values. So over here now, our a is what? 2 over x minus 3. Then our b is what? Our b is minus 4 over x minus 1. So minus times plus, what does it give you? You have 2 into x minus 3. Minus times plus gives you a minus. So you have 4 over x minus 1. So we've successfully resolved the algebraic fraction here into its partial fraction. So just like originally, this is what we have right now. So our problem is solved. Our problem is actually solved. So this is just how you solve this. So I'm going to give you an example to try, and I'll also solve that example in our next lesson. So I'm going to give you an example which I want you to lay your hands on, and also when we are looking for that coefficient in the next lesson, I will show you a new approach which you can actually use to obtain those coefficients. So let me give you the question which we'll be solving them in the next class. So this is your assignment. Resolve 8x minus 28 over x squared minus 6x plus 8 into partial fractions. Resolve 8x minus 28 over x squared minus 6x plus 8 into partial fraction. So we're going to meet in the next class where I'm going to so do it and check up with my own solution whether you're actually correct. And also I'm going to show you a new method of how you're going to get those constants a and b. Okay, so we are going to meet in the next class. And let me tell you, don't think this is not the end of partial fractions. There are rules. Partial fractions has rules depending on how the question is set, but this is the simplest form. This is the most easiest of partial fraction. So we're going to go to the move after lesson 2. We'll keep on moving from one stage to the others. I will show you all the rules, all the different kinds of partial fractions that will present itself that you can actually encounter, whether in your examination, whether in your mathematics, your further mathematics, your additional mathematics work. So before we end, if you know you're not subscribed, just hit the subscribe button. Go ahead and do what? Hit the subscribe button and click the like button as well, and drop your comments on how we can actually help you better as well, and click on the bell icon so that you always be notified whenever I upload a new video. Thank you so much for joining us. God bless you. Bye.